I am starting this review about skin with this picture because it shows skin as well as the epidermal derivatives of skin, namely hair and nails. What it doesn't show are the sweat glands that are present in skin, but then this lady probably doesn't ever sweat anyway. Now, skin comes in two general types. There is thick skin, shown here, with a very thick epidermis, which is present on the soles of the feet and the palms of the hands. And then there is thin skin, shown here, with a much thinner epidermis, which is present pretty much everywhere else on the body. And it may be hairy skin, or it may be non-hairy skin. Skin is comprised by the epidermis, which is an epithelium, as we've discussed, and the underlying dermis, which is a layer of connective tissue, both loose and dense irregular connective tissue. And underlying the dermis there is another layer called the hypodermis, which is not considered part of skin and often consists of large amounts of fat. We'll look at thick skin in some detail because it is in thick skin that all of the characteristics of skin are best shown. Thin skin may or may not contain all of the layers that are present in thick skin. The basalmost layer of the epidermis of skin is called the stratum basale, and it is here that one finds stem cells that are responsible for dividing and producing all of the other layers that comprise the skin. Above the stratum basale is what is generally the thickest layer of the skin, the stratum spinosum. And here one sees these closely packed cells, and they're joined together by desmosomes, and when the tissue is fixed, these cells tend to shrink, leaving little spaces in between them, and at a higher magnification you'd see these little connections between the cells, and those are just the desmosomes holding on to one another, creating this spiny look. Above the stratum spinosum is a dark layer called the stratum granulosum. The cells are being filled at this point with dark staining granules. This transits into the stratum lucidum, which is not always present in every type of skin, particularly in thin skin. And then above the stratum lucidum in thick skin, the thickest layer is the stratum corneum, and at this point the cells are just sacs containing large amounts of keratin, the hardest, most insoluble protein in the body. In thin skin, some of the layers forming the epidermis are lost. We can still see the stratum basale, we can still see the stratum spinosum, although it's much thinner. There's just a very thin stratum granulosum here and a very thin stratum corneum. But some facets of skin are better shown in thin skin. As you can see, there are these ridges of epidermis which poke down into the dermis, and these are thought to provide anchoring of the epidermis to the dermis. Correspondingly, the dermis sends these dermal papillae up in between these epidermal ridges, and the dermal papillae are rich in blood vessels and capillaries, which provide nutrition to the overlying epidermis. Remember, epithelia are always non-vascularized, and additionally these capillaries play an important role in cooling the blood and maintaining the temperature of the internal body organs. dermis is comprised of two layers, a layer of loose connective tissue called the papillary layer, and underlying that is a layer of dense irregular connective tissue called the reticular layer. So let's go back to thick skin and look at the stages in the development, in the synthesis of skin from the cells of the stratum basale up until these thin squamous cells, these dead keratinocytes, are shed from the surface of the skin. And we shed about 1.5 to 2 pounds of these keratinocytes every year. The cells of the stratum basale contain the typical organelles that one finds in any cells, and in addition they contain some 10 nanometer intermediate filaments composed of keratins. And as these cells move up into the stratum spinosum, the synthesis of these intermediate filaments increases, and those intermediate filaments become assembled into bundles called tonofibrils. Towards the top of the stratum spinosum, the keratinocytes begin the synthesis of keratohyalin granules, which eventually fill much of the cell, and it is these keratohyalin granules that give the stratum granulosum its granular appearance. The keratohyalin granules contain a protein called filigrin, the function of which is to bind these tonofibrils together, converting them into the final insoluble form of keratin. Additionally, as these keratinocytes move upwards towards the stratum granulosum, they also produce lamellar bodies, which contain a complex glycolipid. And this glycolipid is secreted between the layers of these cells in the stratum granulosum and forms a barrier to the absorption as well as to the loss of water and also to infection. As these cells are also moving up in the layer of the stratum spinosum, they start to destroy all of their intracellular organelles, and the plasma membrane around the cells becomes thickened. Finally, by the time these cells reach the stratum corneum, the stratum lucidum initially, and then the stratum corneum, they are just bags of keratin with thickened plasma membranes. As the cells in the topmost layer, these squamous cells in the topmost layer, are shed, this causes stimulation of the cells in the stratum basale divide and to synthesize more cells in the stratum spinosum, and thus to replace those cells which are lost. This process of differentiation, division, and finally death of the keratinocytes is summarized in this slide. As we know from looking at skin in your assignment 2, you know that there are a number of other cell types in the skin other than keratinocytes. Those cell types are melanocytes, Merkel cells, and Langerhans cells, or antigen presenting cells. Melanocytes are the cells which produce the pigment of our skin. They are situated in the basal layer of the epidermis, and they're difficult to distinguish from Merkel cells, and we'll look at Merkel cells in a moment. Melanocytes synthesize melanin and package it into granules called melanosomes, and then they push these melanosomes into these processes, and then they transport these melanosomes into processes and pinch off bits of their cytoplasm containing the melanosomes, and these are phagocytized by the adjacent keratinocytes and then form a barrier around or above the nucleus of these keratinocytes, thus protecting the keratinocytes as well as the vulnerable basal cells, which are undergoing division from damage by UV irradiation. So the melanin that you see in the epidermis is largely in the keratinocytes and not in the melanocytes, which synthesize the melanin. Merkel cells are also located in the stratum basale, and they are tactile sensory cells, and the base of the Merkel cell makes contact with the terminal disc of a nerve fiber, and this functions as a mechanoreceptor, that is the detection of touch. Now, it's almost impossible at the light microscope level to distinguish Merkel cells from melanocytes, so if I were to ask you to identify this cell, you would get full marks whether you said melanocyte or Merkel cell. Langerhans cells are found throughout the stratum spinosum, and they display all the properties of phagocytic cells. They are derived from monocytes in the blood. And their processes form a network throughout the epidermis, so it's difficult for invading microorganisms to avoid this. And then once they encounter a microorganism, they ingest it and they travel to a lymph node where they elicit an immune response by reacting with lymphocytes. So they are antigen presenting cells. And this slide also shows the little spinous processes between the keratinocytes of the stratum spinosum.